Hello guys, so today we are here to solve this legendary problem called count sub-islands. In this problem, we are given two binary matrices. So this is a binary matrix, so it is only going to contain two values. Only allowable values which are going to be contained in this matrix are two, and those are zeros and one. And here the zeros represent water and ones represent the land. Okay, and the question asks that an island in a group of ones connected four directionally, an island is a group of ones connected four directionally, that is horizontal and vertical. Any cells outside of the grid are considered water cells. Okay, an island in grid 2 is considered a sub-island if there is an island in grid 1 that contain all the cells that make up this island in grid 2. Okay, so first of all, we are given two matrices, and those matrices are going to contain only zeros and one. Zeros represent water, ones represent land. So this is water, this blue zone is water, and this yellowish zone is land. This is also water, and this is also land, and this is also land. So in this is also, you know, land, this is water, this also is, this zero is water, and this one, if you see correspondingly on this, grid one, it is zero. So this one and zero, you cannot say that, that is, you cannot say that it is, it is to be counted. Okay. Yeah. So now it is clear that, both the grids can only contain zeros and ones, and we need to count the sub-islands, the number of islands which are there in grid 1 as well as grid 2. So see, this whole thing is one in this grid 2 also, and this one and this one, these are there in this grid 1 also. But this one is not there, and you know, and these two, why these are not counted? These are not counted because this one is connected, the corresponding one here is connected with, this island. And you see these two cells are zero. So that's why this sub-island is not counted. Okay. Uh, Let me know if you have any doubts in the comments, and I'll, express it more clearly. Uh, Problem is, little difficult to understand. So what is saying that, we should only count those islands in grid 2 which are, you know, which are those islands which are, present in the grid 1 as well. So this whole thing, this whole red zone is present in grid 1 also, and these two things are present in grid 1 also. This one is also present here, but see, this one is connected with this, and these two zones are, these two zones are water cells. So since this is water cell, and that's why this also is not being counted. Okay, so if you count only one, two, so this is not four directionally connected. It is not horizontally connected nor vertically connected. So these are two separate islands, but this is one one unit of island. So this is one island, and this is one island, and this is one island. So in there, in total, there are three islands. So that is the answer here. Okay. So with this, with this understanding, we will, try to solve this problem. So see, we have to count the islands, and counting islands is, all these flood fill things can be done through depth first search. And I'm going to show that it is very easy to do this problem. So before we start counting the islands, we need to do some pre-processing. So what are the pre-processings that we need to do? So first of all, we need to write, okay? We need to write the loop for end I is equal to 0, I less than I less than, let's say, in the grid. So any grid is fine. Okay, grid one dot length plus I for int j is equal to 0. J is less than grid one I dot length plus j plus j I less than grid one dot length plus I plus j. Okay, and see if something is one in grid two. Okay, so we will if something is one. Okay, okay, so two things are there. If something is grid I, grid j is equal to 1 and grid 2 I j is equal to 0, then in that case, what we will do, that we will make grid 1 I j is equal to 0. So does this matter? Oh, and else, so in the else part, we can do grid 1 I j is equal to 0 and grid 2 I j is equal to 1. So now we are covering these cases. So here this cell is 0, but this cell is 1. So we'll start one, DFS. And what we'll do in this DFS visit grid 2 DFS. Okay, and we'll pass the grid 2, that ith value, that jth value, that's it. Okay, so with this we are done. Okay, and then at this point we'll be creating one count variable is equal to 0 for and I is equal to 0, I less than I is equal to 0, I less than. So same, exactly same, the loop is just the same because both the matrices are having the same dimensions, so it doesn't matter. Right? Hmm. Okay, okay. We'll be calling the same function, not a new function. We'll be calling the same function. I, J, like this. And then at the end, we'll be returning the count. That's it. And then now I just have to complete the visit grade to DFS and array grade and row and call. Okay, if row is less than 0 or row is greater than equal to grid dot length or call is less than 0 or call is greater than equal to grid to grid of I dot then if row is less than 0, row is greater than equal to grid dot length call is less than 0 call is also if grid is water cell, if grid of I j is equal to 0, then in that case we'll just do one return. Otherwise, grid of I, grid of row j, you have to write ROW for row r is equal to 0. Okay, and in this will pass the grid row plus 1 call row minus 1 call done. So this is it. So basically what we have done here, okay, if you see this loop, we have traversed this matrix using the two indexes I and j, and I is starting from 0 and going to grid 1 dot length, and then j is also starting from 0 and going from the 0th value to the you know length of the column, and I is going from 0 to the number of subarrays. So the number of subarrays is grid 1 dot length and number of columns is grid 1 I dot length. And we are checking if grid 1 some cell is 1. So like suppose this cell here is 1, but the grid 2 corresponding cell is 0. So what we are doing, we are making you know that grid 1 ij, so we are making this to be 0. So we are making this to be 0, okay? And then after it, what we are doing, that if something here is 0, in grid 1 it is 0, and grid 2 ij is equal to 1, then we are doing one visit grid 2 DFS. So like this, suppose this one is 0 here in the grid 1, and here it is 1 in the grid 2. So we are starting one DFS visit from this cell, and so we are doing for this cell also. So these two cells, and these two cells, when we start DFS on these any one of these cells, then that will make this cell also as 0. So that's why in the final countdown, 1, 2, and 3 we are not getting, the count of this cell. So with this, we are done with the solution. So let's see. Call is greater than equal to, yeah, it is correct. Correct. Let's run. Cannot find symbol grid. Yes, it should write ROW. ROW. Perfect. Perfect. So this is our solution, and this is beating 66 point. We could have done it better, and in some other video I'll show even better solutions for this. Thanks a lot. Thanks for watching. If you have any doubt, let me know in the comments. So basically what we have done a pre-processing of the grid, and then at the end we have just resorted to simple DFS traversal of that grid, uh, where both the cells in the both the grid are having the value 1. Then we are doing that simple DFS traversal, and whenever we are starting a new DFS traversal, we are incrementing the count, and that count we are returning as the answer value. So that is the solution of this problem. Let me know if you have any doubt. I'll post those doubts in the comments, and I'll surely answer them. Thanks a lot. Thanks a lot for your. Thanks a lot.